15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you for joining us on the podcast known as Space Nuts. My name is Andrew Dunkley. I'm your host, and with me, as always, Fred Watson from the Australian Astronomical Observatory. Hello, Fred.
Hello, Andrew. And look, I do like your newly badged, newly minted style voice.
Yes, it's brilliant, isn't it? As you are aware, but many of our overseas listeners would not be aware, we've just come through, or are still going through, one of the worst flu seasons in history in this country. In fact, in my state, New South Wales, they recorded the worst August on record for the flu, and that only surpassed the worst July on record, which was the same year. So 2017's been a dreadful season. I thought I got through it. We're in spring now. We're getting temperatures up towards 30 degrees centigrade, and I thought, yes, I beat it. I got through without the flu, and then bang, it hit me, and it is relentless. It is unbelievable.
And it's so virulent that even though I am separated from you by 400 kilometres at the moment, I'm worried about catching it from you.
You're taking a big risk. You are.
I am too.
Yeah. You could get the digital flu. Excuse me. There might be occasional coughing, so we're going to press on though. So, Fred, today we're going to talk about the US Vice President's announcement that we're going to go back to the moon. Hello. And the other thing that's in the news at the moment, this is really fascinating, with the detection of Freon 40 in space by the ALMA and Rosetta probes, or Rosetta probe and the ALMA observatory. Freon 40, not to be confused with 40 Klingons. No, that doesn't work. Anyway, we'll keep going. I'm really struggling here. And then we're going to finish up with a story about a Japanese amateur astronomer who has been posthumously recognised for her work and compared to Galileo in some respects. So that is very fascinating. But first up, Fred, and I think you can do most of the talking. I'll just sit here and get into my Lemsip.
Yes, that's right.
When are we going back to the moon?
Well, soon, apparently. And this is a really interesting piece of news that's come actually out of a visit by the US Vice President, Mike Pence, to a body known as the National Space Council. This is it's an advisory body, which is very interesting because it hasn't actually met not for a fortnight or anything like that. It hasn't met for 25 years. So quarter of a century ago, the last time the National Space Council met, which is very interesting. But it's been reconvened, and the speech that Mike Pence made to them really signifies a change of direction in NASA's NASA's mandate and their mode of exploration with the change of administration in the USA, because the Obama administration was pretty negative about flights to the moon. In fact, President Obama was quoted in a recent news report as having said, "We've been there," and that's kind of it, really. Yeah. And really set the agenda for sending humans to Mars, to orbit Mars, and then return them safely to Earth by the mid-2030s, with the possibility then of human exploration of Mars. And it was actually the Obama administration that approved what we call the SLS, the Space Launch System, which is a kind of back to Apollo era style launch vehicle, compared with the Space Shuttle, which of course was retired. And an Apollo-style deep space capsule called Orion, very much the same sort of shape as the Apollo capsule, but bigger. I think the idea is it can hold up to 7 astronauts. Now, all that is still on the agenda. NASA are certainly still working on the SLS and on Orion, but the new administration is very keen on landing American astronauts again back on the moon, and using it as a kind of trial base for spacewalking on different worlds, because that's something you need to get used to, but also in a way to provide what you might call a gateway. And in fact, they are calling it the gateway, the Deep Space Gateway, which NASA is now talking about as a possibility to build some kind of a lunar space station that would actually allow astronauts to train for walking on other worlds, to use their equipment to test all that out in an environment which is a lot more, I suppose, a lot more Mars-like than being in the International Space Station, which is currently where astronauts train for all these things. So this is really very, very interesting. And there was a statement issued actually by NASA's acting administrator, because there is a new administrator going to be appointed. We don't know who that will be yet. But the acting administrator, Robert Lightfoot, last week issued a statement that said, NASA has been directed to develop a plan for an innovative and sustainable program of exploration with commercial and international partners to enable human expansion across the solar system, returning humans to the moon for long-term exploration and utilization, followed by human missions to Mars and other destinations. So it's very firmly back on the agenda. I mean, it's extremely exciting that this sort of thing is now happening. And I think the next thing we see, Andrew, will be the appointment of an administrator for NASA, and that person will set the agenda for the way these things are achieved over the next few years.
Yeah, it's interesting. I actually read an article the other day about maybe putting habitats on places like the moon, and they were talking about maybe setting them up in lava tubes, because they've discovered that the moon has lava tubes and Mars has lava tubes. And some of them are quite enormous and would create a natural barrier for radiation.
Radiation.
Yeah.
Yes, that's right.
So
that's correct.
That's really interesting. I was wondering about when you said that we'd fly to Mars, do a lap, and come back. It's a long way to go, not to land,
isn't it? Yeah, that's right.
But is that definitely the thinking?
Well, that was the thinking of the previous administration, Andrew, and a very cautious, risk-averse policy, and I absolutely understand that. You know, things have changed, certainly in terms of our cheerfulness at taking risks since the Apollo era. I think that people were much less risk-averse in the Apollo era than they are now, and so. And there was, of course, that strong political imperative at that time. But I think you're quite right. It's a long way to go just to come back again. On the other hand, the really dangerous part of a mission like that will be the landing and getting back off the Martian surface. So you can understand that might still be on the agenda. And in many ways, I hope it would be. It's what happened in the case of the moon. If you remember, Apollo 8 flew around the moon, sent back those marvelous pictures of Earthrise before the Apollo landings later the following year.
Yeah. All right, more to come on the moon and beyond. And you're listening to Space Nuts with Andrew Dunkley and Fred Watson.
Okay, we checked all 4 systems and skiing with a go.
Space Nuts.
Now, Fred, we're going to look at the discovery of Freon 40 in space. I won't pretend to know what Freon 40 is or where you'd find it, but I'm guessing it's not on a supermarket shelf. But then again, it could be. But the ALMA Observatory and the Rosetta probe have both found this stuff. What is Freon 40?
Well, look, I'm not really that hot a chemist, I have to say, Andrew, but I believe Freon 40 is an alternative name for a chemical compound with the chemical formula CH3Cl, and of course you'll immediately recognize that as methyl chloride or chloromethane, which is another name for it. And I've got a feeling that I encountered this stuff as a solvent in the years when I used to be working in the fibre optics lab at the UK Schmidt telescope, a very, very effective solvent, which I used for several years until somebody told me it is highly carcinogenic and better left alone. So I promptly left it alone.
So you
after that.
shoved it in a cupboard with your asbestos collection.
Yes, that's right. Something like that.
Yeah.
But as you said, this compound has been detected by ALMA, which is the Atacama Large Millimeter Array, an array of radio telescopes in the Atacama Desert in Chile. It's been found in the atmosphere or the gas cloud around an infant star. So this newly formed star has a cloud around it which is the cocoon within which it's formed, which contains Freon-40, among other things. But it's also been found in a totally independent mission, the European Space Agency's Rosetta mission, which you and I talked about endlessly a few years ago.
Yeah.
The spacecraft that was in orbit around the comet Churyumov-Gerasimenko also detected Freon-40 in the gas cloud around the comet. And so that is a fairly strong indicator that this stuff is around in space, that it forms part of the raw material of solar systems from the ALMA detection, and indeed also from the Rosetta detection, because we believe that comets like Churyumov-Gerasimenko, or 67P as we tended to call it, we believe that those comets are actually samples of the raw material from which the solar system formed. So that's the new observation. But why is this such big news? It is because Freon-40 is part of a class of compounds called organohalogens. And on Earth, organohalogens are basically created by biological processes, or some biological processes. In fact, in ESO's press release, it says they're created in organisms ranging from humans to fungi, as well as by industrial processes such as the production of dyes and medical drugs. So it's the fact that it's created by by life processes that has excited astrobiologists, who are the people who look at the possibility of life beyond the Earth and want to study whether living organisms can exist out there, and more especially to find them. So this discovery is actually a blow to astrobiologists, because we have always thought that when the time comes, and it's not too far down the track, for big new telescopes to be able to analyze the atmospheres of planets of other stars, when that time comes, one of the things that people were going to look for as a marker of biological processes was Freon-40. But now we know that it's not actually guaranteed a biomarker. It can be in the gas cloud from which a planet formed. There's a very nice quote, actually, within the press release that the European Southern Observatory have put out on this, which reads, "This suggests that astronomers may have had things around the wrong way. Rather than indicating the presence of existing life, organohalogens like Freon-40 may be an important element in the little understood chemistry involved in the origin of life." In other words, Freon-40 might be there before life starts.
Yeah.
And so it means that we can't rely on this particular class of chemicals as revealing life on the planets of other stars. And in fact, I was talking last week to a colleague at the University of Southern Queensland, Jonty Horner, who's an astrobiologist, and he said, we really are struggling to find things that would be, irrefutable markers of life processes. One of the things that is often touted as being an indicator of life in the atmosphere of a planet is the presence of oxygen, because oxygen, first of all, it's highly reactive, so it has to be being constantly replenished. But we know that it's produced by living organisms on Earth. But there are other processes that could cause oxygen as well. Jonty's comment was, we need to look for oxygen and methane in equilibrium, which we do find on Earth, and that is, at the moment, the best biomarker we've got. But things like Freon-40, sadly, we've had to throw out of the window.
Yeah, that's interesting, because it changes the whole spectrum of what they're looking at. Is there a possibility that perhaps they'll be able to find other markers aside from oxygen and methane that might help them, find places where life may exist.
Yeah. It's a very, very active field of study, is this, Andrew? So you put your finger on exactly what's happening in the world of astrobiology, that people are looking for exactly these sorts of things. One of the things we were excited about a few years ago was something called the vegetation red edge, which is a feature in the what we call the infrared spectrum of vegetation. So if you've got living vegetation, it causes this particular profile in the reflected light coming from it. It's actually caused by chlorophyll, the green colouring in vegetation. But that now is also not seen as a guaranteed biomarker. What we do is we put these things up and then test them out, and maybe at the end of the day there will be some that stand the test of time and are genuine biomarkers, things that can only be produced by biological processes, and they're clearly the things to go off and look for.
Yes, indeed. All right, but it just takes us that one step closer, perhaps, to finding life. We'll be able to point in the sky and say, "Look at that!
Yes, but
there's something there."
There's something there, but it won't be free on 40.
No, it won't be. All right, you're listening to Space Nuts. My name's Andrew Dunkley, and he's Fred Watson.
3, 2, 1.
Space Nuts.
Well, not too many people would be unaware of the name Galileo and all his achievements. But there is another name that you may not be aware of, and she is from Japan. Her name is Hisako Koyama, and she is being recognised for her work in amateur astronomy, and some of her works have even been compared to that of Galileo in some respects. Fred, this is amazing.
Isn't this a lovely story, Andrew? And it's one that surfaced in the news because this year, 2017, we are commemorating the 20th anniversary of the death of this remarkable Japanese woman, as you said, Hisako Koyama, somebody who was born in Tokyo in 1916, but wound up as an expert in the sun and solar astronomy, solar phenomena. A topic that at the moment is very much a hot topic, and understanding the way the sun works is one of the great scientific quests of our time. The reason why she's been compared with Galileo is because of her work on the sun. And of course, Galileo was actually one of the pioneering observers of the sun. It's probably why he went blind, because he kept looking through his newly invented telescope at the sun to look at sunspots. It's also, just as an aside, one of the reasons why he wound up in front of the Inquisition, because he fell out with another solar observer called Christoph Scheiner. And Galileo maintained that these spots were actually blemishes on the surface of the sun, and he was quite right in that regard. Yeah. They're regions of cooler temperature, whereas Scheiner followed the doctrine of the church. This is back in 1618 or 1619, I think. Scheiner followed the doctrine of the church, which said that the sun was perfect, heavenly bodies were all perfect. So these spots on it could not be things on the sun. They were obviously planets in between ourselves and the sun, which is...
I'll bet you Galileo wanted to give him a shiner.
Yeah, I think he did too, yeah. Very good. You see,
I've still got it. I've still got it. I've got a lot of things at the moment.
Yeah, no. You'll have to get flu more often, Andrew. Yeah. So that caused the schism between, the schism between Galileo and the church, or it was one of the reasons for it. So sunspots played a big part in Galileo's life. Actually, we usually attribute Galileo as being the first person to note sunspots in the early 1600s. 1610 was when he was pointing his telescope at them. But there are records from England, actually, that show in medieval texts pictures of the sun with black spots on it,
yes.
Seen with the naked eye. I think there's one that goes back to the 1400s. It's quite extraordinary. Anyway, we can certainly associate Galileo with sunspots. And now we know, because an author has actually celebrated the work of Hisako Koyama, we now know that she also is very much associated with sunspots. So briefly, the story is that she grew up she was born in Tokyo, and basically as a young woman got interested in astronomy and making sketches of the sun, and made her first sketch of a sunspot in 1944. The telescope was actually a present from her father, and sent the result into what was then the Japanese Oriental Astronomical Association, which was her work was received with enthusiasm, and she was sort of mentored by the then president of the association. And after a couple of years, she got a job at basically a scientific institution. It's now the National Museum of Nature and Science in Tokyo, and stayed there until she retired at the age of 65 in 1981. So that's a pretty long shot.
It is.
And she compiled a record of more than 8,000 sunspots. Remarkable stuff. And those records actually today, they're part of the kind of canon of knowledge that we have about the sun. They are probably digitized. I'm not sure whether they are, but the records are actually used by sunspot researchers as part of the archive of data that we build our knowledge on. So that 400 years of sunspot observations since Galileo had a very significant contribution from Hisako Koyama with her 8,000 sunspots. So what a striking woman. She was described in an article that's published in the journal Space Weather, which of course is all about solar activity, by Dolores Knipp. She's written this article. She describes Hisako Koyama as a most unusual woman of her time who bridged the amateur and professional world, which is a great tribute. It makes you wonder, Andrew, just how many other unrecognized heroes and heroines of astronomy there are throughout the world who we have yet to find out about. I was delighted to read this story, and I think it's a great thing to talk about.
Certainly is, and you're right about her being an unusual case, because she was a Japanese woman at a time when imperialism ruled. The country was run by an emperor when she was born, and and she started making her notes and doing her work during the height of the Second World War, which is quite odd. I would have thought that they would have been pouring all their resources into the fight.
Yes.
And astronomy or studying the sun would have been put on the back burner.
Very much so, and yet this young woman managed to, against all the odds, succeed, and in spite of the fact that at that time it was almost impossible for girls of any nationality to get jobs in science, and yet she succeeded in doing that. And as you said, in circumstances that, well, probably, it will be very hard to imagine today. So good on her, and what a great story.
Indeed. And you ready for this? A glowing tribute to the land of the rising sun.
Oh, thank you very much. Thank you. Boom, boom.
Thank you, Fred, as always.
It's a great pleasure, Andrew, and thank you for struggling through with your little infirmity, and I hope you get better very soon.
Oh, me too. Thank you so much. That's Fred Watson from the Australian Astronomical Observatory, and between he and I, we are the Space Nuts, and so are you, I guess. I mean, anybody who listens has got to be nutty. And don't forget to follow us on Facebook and Twitter. Send us your questions. We didn't get to listen to questions this week, but we'll try and do a couple next week. And stay in touch. We love to hear from you, even if you just want to make a comment. Until next time, thank you for listening to Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor. This has been another quality podcast production from Sites.com.